All right, you're recording. So go ahead and we're gonna just kind of go through this in a little bit of review at the top. So go ahead and just fill these in. Just take a moment, fill those in. What do you remember about each of those? Okay. And we'll just do the top three. So those top three are review. So go ahead and do those.
So this is like guided notes. You're just doing a review right now. You want to look in your notes to find these definitions. What do we call a group of three bases? Write that word down.
And it's only those first three that are review. The rest of it is going to be new information.
So go look in your notes. You should know what these are, or you should be able to find them.
Probably in your learning log. It's probably in
Notes on protein synthesis.
Right.
Protein synthesis notes has this information in the second half of the notes. The title of the notes you're looking for is protein synthesis.
And I'll give you first letter clues. Those are your first letter clues. Oh, yeah.
It's on page 3 at the top of your protein synthesis notes.
Where specifically? If we're struggling to find these, then you know that you need to figure this out at this point. All right. What does the C stand for? Heard it? What? Codons. Those group of three things coming in. Remember, yesterday we practiced doing those in groups of three. We had the gray one, the white one, the gray one, the white one. All right, what's the building block of proteins? I heard it somewhere. What is it? Amino acids, right? That's when we had those, they were connected to that tRNA. They came in, they attached in those codons, and then each one would release and would attach to the next one. What is the molecule, or what are the molecules called that do those jobs? All right, here is some new information now. All right, a change in DNA. Anybody know what this might be? It's the title of what we're doing, yes. Mutations. It's the thing that went wrong. Right? If you remember Maggie, we said Maggie, there was something wrong with her DNA. Yesterday, there was normal DNA, normal genes, and then there was Maggie's gene. Because she's got a genetic disorder, that's caused by mutation. There's different kinds of mutations, so let's do these things. If there is something added, like if there's the normal DNA, the normal gene, and let's say all of a sudden we add a thymine, a letter T, or we add like guanine, so the letter G. That's called an insertion. So what we've done is we have all of these, and then all of a sudden, doesn't matter how many squares you've got, all of a sudden a new base is inserted into that string of genes. If I remove one of those bases, It's called deletion. And so that again is where I've got my string of bases. And I take one of those out. So one of those bases is going to come out of that gene sequence. And the third kind, there's other kinds, but the third kind we're going to do is called substitution. And if your art isn't super great, that's okay. We've got lots of images coming up. Thank you.
Is there anyone online?
Nope. All right, so a substitution is exactly what it sounds like. So let's say I've got one base pair. Let's say it's the letter T. And so that base comes out and another one goes in. Right, so it just takes the place of it. So if nothing's being inserted, it still has the same number of bases. It's just, it's switched out. This one now, it's got, so when we're doing insertion, now it's got one more base. And when we do deletion, it's got one fewer bases. Okay, all of them are mutations that's going to cause a different amino acid to be synthesized. All right. First one, DNA is read in groups of 3 bases called what again? Codons. Excellent. All right. Each blank codon codes, each blank codes for one blank. All right. So each codon, I'm just going to keep using this word. And it codes for one amino acid. So we've got 3 things. And I just really want to drive home this point. It's not one base that creates that amino acid. They're always in groups of 3 that make those amino acids. And then amino acids link together to form a protein. So this is the result. This is why mutations are a big deal. Because if the codons change, right, even if one base in the codon changes, the amino acids change, that means the protein may not work correctly. So even if it's one base, sometimes it's more than one base. Even one base. So it's this chain reaction or chain effect. All right, so these are those mutation types that we are talking about. Right, so this is the normal. This is what it's supposed to be, ATC, GTCA. A deletion is, okay, they took out that T, so what happens is now this is our codon. So before it was ATC, and now that codon is ACG. So we've got a new codon. If we have a new codon, what's gonna happen? what's going to change? We have a new codon. So if I change one of those codons, what's going to happen? You guys, I'm going to wait. If I change the codon, what's the result? Okay, tell people at your table. If your codons change, tell the people at your table what's going to change. Okay, so if that amino acid changes, then what happens? Yeah, so that means you're going to get a new trait. It means the thing that's supposed to happen, so it's going to malfunction. It's not going to do what it's supposed to do, or it's going to do something that it shouldn't do. All right, so in this case, with substitution, what happened is this is supposed to be a T, and now it's the letter A. So it's not T, it's supposed to be T. That thymine came out and an adenine went in its place. Does the codon change? Right? It's supposed to be ATC. That's normal. Now it's AAC. It's going to give you a different amino acid, which means it's going to give you a different protein. If one amino acid changes, the whole protein changes. We're not going to worry about inversion. Insertion means, okay, so it was originally ATC, but now they've inserted, or not they, a G has been inserted in between the A and the T. So what's going to happen to if our codon changes, what changes? The amino acids change. So now it's not ATC, it's AGT. Because then it sort of looks like, okay, everything after then is going to be okay, but my next codon should be GTC. If I've taken that out, now it's TCA. All right, so we've inserted one. Duplication, bless you. Don't worry about duplication. We're just going to look at deletion, substitution, and insertion. Those are the only ones we're going to be looking at because those are the most common ones. All right, here's what you're going to do. On your whiteboard, I want you to write the 3 words. Deletion, substitution, insertion. Go ahead and write those on your board. So let's add this note. What happens to my string of letters? Does it get shorter, longer, or stay the same if I'm doing deletion? It's going to get shorter because I'm taking something away. If I'm doing substitution, is it going to get shorter, longer, or stay the same? Because I'm just swapping it out. If you have a substitute teacher, Mr. Burns is gone, another teacher comes in, you still have the same number of teachers. If Mr. Burns and I are both gone, we have 2 substitutes, you still have the same number of teachers. For insertion, shorter, longer stays the same? Longer. This one you can actually see that it's like there's an extra one in there. This one, it's really hard to show that it's shorter. But if I just count it 1, 2, 3, 4, 5, 6, it's still, oops, 1, 2, 3, 4, 5, 6. Oh, what happened? Yeah. Okay. They just stopped it right there, apparently. Okay. Let's turn the page. All right. So what I want you to do is I want you on the final project, it's going to look like this. You are going to have a section that looks like this. So we would like to have you do some practice with this. Practice that base pairing rule, just like we did yesterday. Name the process of going from that DNA to that mRNA sequence. Ooh, that's kind of fuzzy. And then fill in what that amino acid is. What are those amino acids that are going to come from each of those codons using this table up here? Okay, so that's what you're going to have on the assessment. So go ahead, practice this.
Now you're doing this. We did this together yesterday. Mr. Freeseth has introduced a few kinds of mutations. Now you're going to do it. See if you can go through the process. The first one does not have a mutation, correct?
Correct.
The first one is
This
just
is normal.
normal. So we're going to practice how do we figure out the amino acid sequence.
All right, go ahead and do that.
You can look in your...
I'll be honest, one of the easiest ways to kind of check if you've got it is you can go through and check all the letters, but if you check the amino acids, that's one of the fastest, easiest ways to check your amino acids. They're not always going to change because of a change in the bases, because remember, you can have different combinations. But, yeah. So I'm just going to read across if you want, kind of look at yours. I feel like I'm reading bingo. AUG, CAC, GUG, GAC, UGU, GGA, CUC, CUC, UUC, AGA, CGG, UGA. All right. So then your amino acids. Oh, what's the process called of going from DNA to RNA? Yeah, so we first transcribe it. And again, the format is going to look exactly like this on the final project. All right, so now let's double check your amino acids. So met, his, val, aza, I don't know, cis, gly, lu, fe, arg, stop.
So when we assess this, we don't actually need to look at anything other than that last sequence. Because if you don't do the other steps correctly, you'll get the last sequence wrong. So we're not going to need to grade your RNA necessarily unless we notice that you get your amino acid sequence incorrect.
All right, so what is that process of RNA to amino acids? Translation. It is easy to mix those up. So just make sure you're double checking that you're transcribing it. This is a new language. Again, I sort of think about this is how I translate something. I say something in one language, and then I say it in another. This language is base pairs. or bases. And then this new language is amino acids. Transcribed means I just wrote it with different letters. All right. The other thing that I want to point out is the genes, the normal genes, will always start with met, and there'll be a stop codon at the end. All right. Let's flip it over. Again, just kind of a review. Different ways of looking at it. I just put in a variety of different images just in case it makes more sense in another way. Again, we're just looking at deletion, substitution, and insertion. Don't worry about inversion. That basically means that it's just, they're still in that line and they're just swapping places. Duplication just means I put in two of the same thing side by side. So don't worry about them. Okay. Go ahead and fill in the blank. What does it mean if you've got substitution? Try that on your own. Changed. Yeah, they're all changes. So that would be true. Switched. Traded. I don't know. There's lots of ways I could kind of think about those. Pick a word. And for this one, only one codon is changed. Usually. And so because of that, it's going to change only one amino acid. It's that normal amino acid is switched out for the wrong amino acid, but everything else is the same in that line. Because it doesn't have that sort of ripple effect, that chain effect. All right. So in this one, T is supposed to be there. But in this case, the T is removed. And I'm going to use James' word. So A replaces it. Or goes in its place. And so again, ATC is now AAC. I still have that GTC afterwards. I still have that GTC afterwards. This is the only change. Everything else and everything before it is still normal. means sometimes the effect is not that great of an effect. Sometimes it is. Because it still might code for the same amino acid. Usually not. All right. So those are called, sorry, forgot to point this out. Substitutions are what's called a point mutation. So it's only mutated at one point. So that's why it's called a point mutation. All right, now turn. Okay, so now what you're going to do is you're going to go ahead, look at, this is the normal DNA sequence. Now you're going to do this mutated gene. It could be Maggie, could be somebody else. Go ahead and do this process again. Again, we're just trying to get as much practice at this as possible. And trust me, it will go faster the more you do it. This is transcription and translation. So it should be this sequence. What is the normal sequence if we go back to this? Where did the problem happen? Yeah. Yeah. So that PHE here should be what? What was the normal one? Oh, sorry.
HIS.
Yep, the HIS is the one that's wrong. Right? So it should still be Lu and then PHE. So then this is where that problem happened. Because it should be cis-gly Lu, and then Lu PH arg. And so this is in place of that Lu. Well, why? What happened? Well, it's supposed to be an A, but it's a T. So the T instead of the A. And so what that means is it's the wrong amino acid. But you can see that everything else after it is the same. So all of this is the same as all of this. That didn't change. So this is still the same as normal. So it's just a point mutation, 1 point. All right. So for insertion, a DNA base, what happens to that DNA base if it's inserted? We're just adding it in. And then all of the codons change. It changes all the codons after that. Because it always reads in that left to right direction. So we still have this changed, which means this changes. And then we have an extra base pair. And because it's the start codon, it means it won't even create the amino acid.
But we won't just stop. You'll still do the whole thing, even if the
Yes.
Don't just say nothing will happen after this unless you're going to write a description of that.
None of yours will be like that in the assessment. Okay. So here's what we're going to do instead. For this one, I want you to find where it went wrong. Where did something get inserted? See if you can figure it out. And again, I use that idea of use a piece of paper, figure out where did it go wrong. You see what happened? Where did it get inserted? What got inserted? Yeah, so I still have this G, and I still have the A, and I still have the C, and I still have the A. So this one here was inserted. So then everything else is going to be the same after that. And I'm just going to write it down. You all don't need to. If you want to, it might be faster. You double checking my work, Mr. Burns. Please do. All right, once you've got this, go ahead and pack it up. Did you pause it?